at Stanford University.
Okay, well, welcome to Stanford CS193P, winter of 2015. This is lecture number 5. And today we're going to finish up what we were talking about last time and talk a little bit about Objective-C compatibility because, of course, iOS was originally written in an entirely different language. And so there's a little bit of bridging between the Swift world and the old world. And we're going to talk about an example of using any object, which is property lists. And I'm going to do a kind of a brief demo even showing you that. Then we're going to move on to a completely new topic, which is views. So views are how we draw and how we handle touch input in our UI. And so we're going to go over that, and I'll be having a demo for that as well. So I'm going to blast through these slides pretty quick. As usual, the demonstration is probably a little more elucidating than some of the slides, because when you see it in action, it's a lot easier to understand. Okay. So Objective-C compatibility. So virtually all the iOS API, this API that was written over the last however many years in Objective-C, is available from Swift, and you can't even tell the difference. Okay, it's just kind of automatically made available. And when they designed Swift, they went to a lot of trouble to make sure that it could be done in a very compatible way, so that all of the iOS API would work just fine in Swift. There's a few special data types, though, that they've gone to special care to bridge between the two languages. And this makes using iOS APIs from Objective-C much, much easier in Swift. And so I'm going to talk briefly about those. One is NSString. That is the old way that strings were represented in iOS. And that is bridged interchangeably to Swift's string. You can't really even tell the difference. If you have a method that takes an NS string, you can pass a Swift string in there, and vice versa. Okay? They're just automatically treated as if they were the same thing, even though they are quite different things. String in Swift is not even a class. Okay? It's just a struct. So they've done some miraculous work to bridge these things. NSArray, which is the old array, is bridged to array of any object. Okay, so anytime you see an array of any object in an iOS API, it's because it was an NS array before. Okay? Then NS dictionary is an interesting one. It's bridged to dictionary where the keys have to be subclasses of NS object, and the values are any object. Okay? Now, you might think, oh, that's going to be a problem, and I'll explain a little bit why that's not in a moment. And then, of course, int and float, double, bool, they're all bridged to NS number. We talked briefly about NS number. We talked about the NS number formatter and all that. So NS number was the old Objective-C object that just meant any kind of numeric value. And so anything that used to take an NS number, you can pass a double or float or int in there, and it'll just work. Of course, coming back the other way isn't automatic because it doesn't really know necessarily what you want. But you can use the methods like double value or int value, like we use double value in the calculator. And of course, int and float and double are also bridged to the C types, int, float, and double. So you had an API that takes an int, a C int. It'll be bridged to take the capital I Swift int. So this stuff all just works completely automatically, and you don't have to do anything, and it just works. However, if you want to be explicit about the type, you can cast. Okay, so it is perfectly legal to cast a Swift string to an NS string, and it will always work, so you don't need as question mark. Okay, it's all 100% guaranteed cast. And then once you do that, you have an NS string instead of a string, and so you can send it messages that are in NS string. Although you want to be careful with some of them, like length is an NS string method. That doesn't exist on string. It doesn't exist on string for a reason, because we talked about this before. The length of a Unicode string can vary compared to the number of glyphs you'll see on screen. And the new Swift string deals with that, and the old NS string doesn't really deal with that properly. So you got to be careful when you start calling NS string methods that there's not. You want to look for a string equivalent and use that if you can, because it's newer and it does things a little more accurately. But NS array is the same thing. You can cast from an array that you have in Swift to an NS array, and then you can call methods in NS array, like components joined by string, which is kind of cool. It takes all the components in the array, sends them description, takes those descriptions and joins them by the string you pass as an argument. This is the same as the join method in Swift's string. Okay, so you can look at the documentation for string and a string and NS array, but pretty much all the things you can do there, or most of them anyway, are available in the Swift versions. But again, if you're passing them back and forth, it's all automagic, so we could say. Now, you might get a little concerned about dictionary because dictionary, the key has to be an NS object. And of course, we know that string and array and dictionary in Swift are not even objects. Okay, they're not any object, or and they're not an NS object for sure. But you can still pass them anywhere you want to pass an any object or a subclass of NS object because they are bridged to classes that inherit from NS object, because NS string, NS array, and NS dictionary all inherit from NS object. So that means strings, Swift strings, can be the keys in a dictionary, an NS dictionary, even though it requires NS object, okay? And of course, all three of them can be the values, because even though they're not really objects, they are structs, they are bridged to things that can be, okay? So it is okay to pass a string or an array to any object. You won't even notice this bridging 99% of the time. It just happens automatically, but I just wanted you to know that that's going on, so you don't get kind of confused when you start seeing NS string, NS array, what's going on. Okay, they're just being automatically bridged for you. All right, so we talked about any object last time, and I'm going to talk about a use of any object, which is called property list. So property list is not a type or anything like that. It's just a term that we use, and the definition of that term is it's an any object. A property list is any object that is known to be, behind the scenes, one of those 6 classes: NS string and array, dictionary, number, data, and date, or bridged to with Swift, okay? So why do we define this property list thing? It's an any object. It's kind of unwieldy because you have to do a fair amount of casting, ising, and asing, because any object, of course, to use it, we have to kind of cast it. And so why do we have this thing? 2 reasons, really. One, property list is used to pass data around blind. It's like a cookie, right, in a browser or something. It's kind of this just bundle of data that only the creator of it knows how to interpret it, because only they know what strings, arrays, dictionaries, and stuff are in there. But to everyone else, it just looks like any objects, so they don't know what it is. So all they can do is pass it around to other things. So it's good for blind data passing. The other thing is, a property list can be used as generic data structures. Okay, since it's got arrays and dictionaries and numbers and dates and all that in there, you can turn a data structure like our op stack in the calculator brain. It has op enums in there. That's not a generic data structure, but we could turn it into a generic data structure, for example, and then do things with it like write it out to disk or send it over the network or things like that. So those are the 2 main reasons we use property list. And a really good use of property list in iOS is NS user defaults. So NS user defaults is like a really tiny little database, and it only knows how to store property lists. Okay? And it's really for things like settings and preferences, stuff like that. You would never, it's not high performance. You would never use it for big things like images or anything like that. Just property lists, you know, dates and strings and doubles and things like that. It can store and retrieve any property list, and it just stores it like a dictionary, as if the NS user defaults thing itself is a dictionary. And it can store the whole property list, like set object for key, that first method you see there, and retrieve whole property list. Or it can just do little tiny pieces of property list, like it has a method set double that will just set a double for a certain key. Okay? So it's like a dictionary in that it's key value, but it only stores property lists. And the big thing about the way it stores them is that it persists when your app is gone. Okay? So, you know, normally a dictionary is stored in the heap. As soon as your app quits, it's gone. But this stays around so that when your app launches the next time, all the data is still there. So that's why it's kind of like a database, but it's very small, okay, for preferences and settings. Here's how you use NS user default. You use this type method in NS user defaults called standard user defaults. This gives you an instance of an NSUser default. You're always going to use this same instance. It's like a shared instance. We always use the same one. And then you just send it messages like, you know, set object for key, store this property list, and get object for key to get it back. Now, the changes you make in there are automatically saved, but there is a method called synchronize, which is kind of like save, which can force it to save out to disk. Why do you ever need synchronize when it auto-saves? Well, it auto-saves when things happen like your app stops being the frontmost app. It's not, the user switched to another app. And so your app is still there, but it switched to the background. It'll save then. So it won't always save when you want, and especially when you're debugging, okay? When you hit stop in the debugger, it doesn't save, okay? And so you probably want to throw some synchronizes in there to save this thing out, especially when you're debugging. It's not really that expensive to synchronize, especially if there's not much data in there, which there shouldn't be because it's small. So you can't hurt too much to throw them in there, okay? And yeah, synchronize returns a bool, whether it failed or not, but if it failed, there's not really much you can do. So a lot of times people don't even look at the return value of synchronize. They just synchronize and they pray. But it's only not going to save if like the disk is full or something, which virtually never happens. So. All right, so I'm going to do a little demo here, show you a little more about property lists and also any object, because you've never seen any object in action. And what we're going to do is we're going to add a property to our calculator brain, which gets its program. Okay? So our calculator brain has a program, especially your versions where you added variables to it. It's got this kind of program. So it's like a little computer program, and you can execute that program, set its variables. It's great. So it'd be nice if we could get that program. But we don't want to reveal our internal data structure, and there's nothing anyone can do with that program. So we're really just getting it as a cookie. And the only thing you can do with it is give it back to the calculator brain or another calculator brain in the future and then say evaluate. Okay, so you see the value of having this? It's basically getting the program out of the calculator brain and set it back. But we're going to return it as a property list. It's going to be any object. People are going to look at this var, and it's going to be of type any object, and all they can do is get it and then set it back. Okay, so what would that look like? Let's go over here to our calculator. So I've gone much bigger font here. Hopefully everybody's this big enough. Yeah? Okay. All right, so this is a calculator as I last left it. It doesn't have your enhancements to it for the variables. And I'm just going to add a var here, a public var, okay, called program. And it's going to be type any object. But I'm going to put a comment here that says guaranteed to be a property list, so that callers know that this is a property list. So for example, they could put it into NSUser defaults, or they could write it out to disk. I haven't taught you how to write out to disk, but you can do it. So they could do that with it because they know it's a property list. Okay, so this is going to be a computed property. Okay, so we're going to have a get and a set. And when the get, we're just going to get some sort of property list representation of our internal data structure. And when you set, we're going to take that property list and turn it back into our private representation. So the get, how are we going to represent ourselves as a property list? Because this is really our internal data structure here. It's an array of op. Op is an enum. Clearly, enums are not NS dates or NS strings or NS arrays, so we can't just return this thing, okay, because that's not a property list. So we need to return some sort of property list, and I'm going to return an array of strings. And the string is either going to be the symbol of an op, in which case I'll look it up in known ops, or the string will be a numeric representation of the string, of the operand rather, right? The double turned into a string, which I happen to have a var that does exactly that. Okay, this turns an enum op into a string. And I know how to turn it back because I know how to use a number formatter to turn the string of an operand back into a double. And obviously I know how to look up binary and unary operations in our known ops. Okay, so we could say something along these lines. You know, our get, I'm going to show you a much better get in a second, but one way we could do our get is we could just say, we could make a return value that is going to be an array of string. Okay, in fact, let's just create an empty array of string here. And then we could just go through our ops in our op stack here. And for each op, we could just say return value, append an ops description onto the end of it. And then we could return value. Right? Makes sense. I just turned my internal data structure into a property list because this is a property list. And notice I can return this through any object because arrays are bridged to NSArray, which happens to be an object. Okay? But this is an awful lot of code for this. We can actually do this in one line of code. Okay? So if you paid attention in my last lecture, you remember that I told you about this function called map. And I can actually just return my op stack mapped so that each element's description is returned. So I don't need any of this. Okay? So everyone understand this line of code right here? This is just a little closure that gets the opportunity to convert every single thing inside op stack, which is an op, these are ops, into a string. And it takes this string and maps them all and returns a new array. Okay? So when you start getting familiar with Swift and what it can do, you'll start realizing a lot of things that take 5 or 6 lines of code, you can just do them in one. Okay, but it does take some experience. So now let's talk about going the other way. So now we have, someone gives us back our program. We want to load our op stack back up. Well, the first thing we want to make sure is that the thing that they're giving us back is an array of these symbols. Because they could just give me junk, because it's any object, they could set it to anything. So I want to make sure that's what it is. So I'm going to do, I'm going to let op symbols equal new value, right? New value, remember we are in the setter here. So new value is the new value, which is an any object, as an array of string, because that's what it has to be. If this thing that they passed in is not an array of string, I don't know what to do with it. So really here what I want to do is if let as question mark, because they could pass me anything. And so here I'm using the as to make sure this any object they pass me is actually an array of strings. Okay? If it is, now I can convert back. So I'm going to create something called my new op stack, which is just going to be an array of ops. And I'm just going to go for each op symbol in this op symbols. Op symbols is this thing right here. All right, so that's the array. That's the new value, the any object converted into an array of strings. Okay? So for each one, if I can find a known op that matches that symbol, then this must be an op. And so I will just add that op to my stack. Otherwise, I'm going to see if I can turn that string into an operand. And I'm going to do that with if let operand equal ns number formatter. Okay, number from string. I'm going to pass it this op symbol that I got out of that array it gave me. Now I'm going to use optional chaining here and put a question mark and then double value. Okay, remember optional chaining. If you have an expression like this whole expression, and if anything along the way returns nil, then this whole expression will return nil if you put a question mark after that term. So number from string can return nil if this is not a string that can be interpreted as a number. And so by putting a question mark here, it says, okay, if that's nil, then just return nil back to here. Otherwise, keep going and send it double value. So this operand is either going to not get set because of the if let, or it's going to be a double, which is what this double value comes out of here. Okay, so that's kind of explaining from last week how we did this number formatter thing. So in this case, I can just append onto the end of it that a new op, so we'll say dot operand with that operand. So we're just putting a new op on there. So now I've built a new op stack using all those strings, and I can just return that new op stack. Not return it, sorry. I'm going to set my op stack equal to that new op stack. Okay? That's it. Any questions about that? Yeah.
So why do you say guaranteed to be a property list? Like that's just because
this is documented. This is a public thing. It's not private, and I'm just documenting to anyone who's using it that this is true. I could document this even better using a type alias. So you can basically have a type alias, which is an alias for a type. It's just a way of another type. And I could have a type alias called property list, which just equals any object. Then I could have this type be property list. Okay? So I just created property list as an alias for any object. So someone looking at this is going to go, whoa, what the heck is property list? And then they're going to look at this type alias and say, oh, that's any object. But they're really going to understand that I'm returning a property list here. And the reason it's property list, again, so I can throw it in its user defaults or whatever. Okay? But otherwise, it's only good, the only thing it's good for is giving it back to me to reset my program in the future. That's all this thing is good for. Now, you're going to want to add this to your assignment for assignment 3. Okay? So, all right, back to slides. I don't have time to really run this, unfortunately, due to test code because we are schedule constrained here. So let's go back to here. Continue. All right, so now let's talk about new thing here, which is views. Okay, totally new topic. A view, that is to say, a subclass of the class UI view in iOS, represents a rectangular area on the screen that defines a coordinate space to draw in and also to handle touch events. Okay, that's what a view is. And you are going to learn today how to make your own views. The views are hierarchical, so views are within views are within views. Any view only has one super view, right? It's only contained directly in one view, but it can have any number of subviews. So in our calculator, we had a top-level view, which I'm going to talk about in a moment, and then we had a lot of subviews. All the buttons, the labels, those are all UI view subclasses. Okay? And so we made a whole bunch, there's a bunch of subviews in that view. But we can go even deeper. It's hierarchical, multi-layer. We can go as deep as we want. You can see the two properties there for getting your super view. Notice it returns a optional. That's because you can have a view that's not currently on screen. It's not currently in a view hierarchy, of course, so that could be nil. Your subviews, I show array of UI view there. Actually, the subviews property is an array of any object, again, for historical reasons, but there will always be UI views in there. So don't even worry about that. Okay? And usually in this class, on the slides, if something's an array of any object, if there's going to be a certain kind of thing in there, I'll say array of the certain kind of thing. But when you write your code, then obviously you might see, oh, that's array of any object. And that's, again, the bridging will work here automatically, so there's no worries there. UI window, there is a thing called a UI window. It's a subclass UI view, but it has no meaning really in iOS. There is a UI window. It's at the very, very, very top of each device screen, but you never send it any messages really. You don't interact with it. It's all about views. Okay? On a desktop, windows matter, but on iOS, it's all about views. Okay? So don't worry about UI window. This hierarchy of views, subviews and superviews, is created usually graphically. You drag things out in your storyboard, and you can drag views inside other views to create your hierarchy. But you can do it in code as well. It's pretty rare to do it in code, but you can. There's two methods here, add subview and remove from superview. Add subview is sent to the prospective superview, in other words, to the place you want to add this view into. And remove from superview is sent to the view that you want to remove. So these are sent to different people. Okay? Remove from superview means remove yourself from your superview. All right, so where does the view hierarchy start? Where's kind of the root, the top level of this view hierarchy? And the answer is very simple, but for some reason students have a very difficult time understanding this one. There is a property in your UI view controller called view, and it is the top level view in the scene in the storyboard. Right? So you have this storyboard, you've got your scene that we've seen, like your calculator one. The top level one, the place where you're going to add your top level views, is called view in your view controller. It's just a property in your view controller. So it really couldn't be simpler. Okay? But sometimes students, they just forget that that's there, and they're like, oh, how do I add something to my storyboard, you know, in code or something like that? Well, you just add it to the view of your UI view controller. Okay? So let's talk about initializing a view. As usual, as I've kind of recommended, you probably want to avoid doing an initializer if you can. So initialize any properties in your view, hopefully using equals or some of the other ways we talked about doing it. But in UI view, it's actually slightly more likely that you might want to have an initializer. So it's a slightly complicated thing, only slightly, in that UI view has two initializers that you have to deal with. And that's because UI views can be created in two different ways. In code, by just saying UI view and this frame initializer, which is just the frame in the super view coordinate system where this view is going to live. But then there's also this init with coder, and I'm not going to talk about coders and archiving and all that, but that is the initializer that is called when the view comes out of a storyboard. So if you create a view by dragging out in a storyboard, its initializer is this coder thing, okay? So if you absolutely have to use an initializer to initialize something in your UI view, you're going to want to implement both of these things. And I recommend this kind of format here, where you override init with frame there. That is a designated initializer in UI view. And then there's actually a required initializer, which is the decoder one. So if you implement the init with frame, you have to implement the coder ones required. Because then as soon as you implement the init with frame, you'll no longer inherit all of your designated initializers. You won't inherit the init with the coder. So basically implement them both and then just factor out your initialization code into some setup method or something and call that. Okay? So that's only if you absolutely have to have an initializer. All right, there's another alternative to initializing, which is if you can wait until the initialization is finished, but you want something really early in the view's life, you can implement this method awake from nib. But that only works for views that come out of a storyboard. Okay? Awake from nib means I just awoke from coming out of a storyboard. So now you can initialize me. So it's a little bit limited because it only is good for views that come out of a storyboard, but it is an alternative. Now, okay, so that's all I want to say about that, actually. All right, so let's go on to how do we draw and handle events in this rectangular area. Well, we need a coordinate system to work in. So there's some data structures I'm going to show you real quick to get us started here that we're going to use when we're drawing and handling events. First of all coordinates are going to be CG floats. Okay, CG floats is a type in Swift struct, and always use CG float when you're drawing or handling events in a view. Do not use double, do not use float. If you use those in your homework, you're going to get dinged, okay? CG float. Now, doubles and floats can be converted to a CG float using the initializer. CG float has initializers for floats and doubles that you can pass and turn it into a float. But you always want things to be CG floats when you're working in the coordinate system, okay? Now, there's a couple other structs that are important here. One is CG point. It's just two floats, x and y. It just defines a point in the coordinate system. Couldn't be simpler, okay? And there's also CG size. Just defines a width and a height in the coordinate system, okay? So these are just simple structs. That's all they are, structs. I don't know, certainly point I don't think has any other methods on it or anything. Size, maybe, I don't think so though. But these two are combined, the points and the size, to CG rect. So a CG rect is a struct that has a point and a size. The point is the origin of the rect, upper left, which I'm going to talk about in a second. And then the size is the width and height. Now rect has a lot of methods on it. Okay, rect has things like min x, which is the left edge of the rect, or mid y, which is the midpoint of the rectangle vertically, or intersects, and you pass it another rect, and it'll tell you Boolean whether it intersects that rect, right? The two rects overlap. Or intersect, which says take this other rect and create a smaller rectangle, which is the intersection of those two rects. Or contains point, okay? Where you pass it a point, and it'll tell you whether it contains that point. So rect, it's a struct, but it has a lot of cool methods in there. There's a whole bunch more. You can just type a rect type and then a dot, and let Xcode show you all the cool methods it has, okay? All right, so those are the kind of data types we're going to use to talk about our coordinate system and to write our code in our coordinate system. So let's talk about the view's coordinate system itself. First of all, origin upper left. Some of you might be used to origin lower left, like Cartesian coordinates, the origin is in the lower left. But all the origin that you use in a view is in the upper left. So that means increasing y is down the screen. Increasing x is across. So I put an example 500, 500, over there. It's 500 across and only 35 down, okay, from the upper left. The units that we're talking about here are points, not pixels, okay? Very high resolution displays have more than 1 pixel per point, okay? Because they're able to draw very fine curves, very fine text, etc. You don't usually care about the difference between points and pixels. It's automatically handled for you because you're doing things like drawing text or drawing an arc, and the system automatically uses as much pixels as it can to make things nice. But occasionally you do care because maybe you're drawing something very finely detailed and you want to control on pixel boundaries. And if you want to do that, you can get this property in View called content scale factor, and it will return the number of pixels per point. So on a Retina display, that's going to be 2. On a non-Retina display, that will be 1. It could be anything, though. Okay? So you shouldn't write your code assuming it's 2 or 1. You should just write your code, get the content scale factor, and you'll know how many pixels per point. Okay? 99% of the time, you don't have to worry about this, but in your assignment 3, hint, hint, you might have to. Okay? So what about the boundaries of where drawing happens? You've got this rectangular area. Well, there's a very important property called bounds, which is a CG rect, which describes the area you're drawing in your own coordinate system. Okay? It's important that it's in your own coordinate system because these views can be scaled and even rotated and translated to other coordinate systems, but when you're using the bounds and you're drawing yourself, you have this rectangle, you know where it is. Now, the origin of your bounds usually is 0, 0, but you could define it to mean something else. For example, scroll views, they define their origin to be where they are in the thing they're scrolling. That's just what they define origin to be. But 90% of the time, your origin is just going to be 0, 0. And so the width and height is what you're going to care about. How big a space am I drawing into? There are 2 other properties that often get confused with bounds, but don't let this happen to you. One is center. Center is the center of your view rectangle in your super view's coordinate system, not in yours. So if you write code that says, oh, I want to start drawing something in the middle of my rectangle, I'll get center. That's wrong, okay? Center is in your super views. Center positions you. It has nothing to do with how you draw. It just says where you are in your super view. Same thing, frame. Frame is a rectangle in your super view's coordinate system that contains you. Okay? It contains all of you, of your drawing. But it's in your super view's coordinate system, so it's only good to position you, not for drawing. When you're drawing, you use bounds. To kind of give you a picture of this, it's better. Like you might think that the frame size is exactly the same as the bound size. Right? If it's a rectangle that contains my rectangle, it must be exactly the same size. But no, because views can be rotated. Okay? And if you rotate your view, like this green view, look how much bigger the frame is. The rectangle that contains you is much bigger than you because you're tilted, right? Make sense? So don't confuse frame and center, which are about positioning, with bounds, which is your size, the area that you're drawing into in your own coordinate system. Okay? Okay, so creating views. How do we create views? Most often, views are created by dragging them out into your storyboard. Okay? That's 95% of the time. But of course, your views aren't sitting in the object palette. There's buttons and sliders, but there's no your view. So you have to drag out a generic view. It's kind of at the bottom of the palette. You just drag it out. Once you drag it out, though, you have to go to the identity inspector and change the class of that view you dragged out so that it's your class. Okay? So it's a 2-step process. You drag your custom view out, then you change its class to be whatever your custom class is. On rare occasion, you might create an instance of your view in code. Probably never in this class, maybe in your final project, I doubt it. You just do that using UI views frame initializer, right? So you just say view equals UI view frame. You can even do UI view with no arguments. It'll give you a CG rect 0, which is a frame 0 size and width, and then you could later set its frame to position the view. So here's an example of creating a view in code. I'm going to use UI label. A UI label is a subclass of UI view, so I can send it UI label parentheses frame. So I just give it this frame, which is kind of in the upper left. Notice I've created this view, but it's not on screen yet. Okay? Assuming this code here is in a view controller, I could then say view.addSubview, because remember, view is a property in my view controller, which is that top level view. And I can say add subview of the label, and boom, it'll appear on screen. Okay, at 2020, width 100, height 50. Okay, so it is possible to create views in code. We almost never do that in iOS. We use storyboards. Okay, so when do I want to create my own UI view, right? Well, when don't you want to? Well, you don't want to if you want a button or a slider or anything where there's already an iOS view. But if you want to do something that those things can't do, draw something special or handle touch events like swipes and taps and pinches differently or for a different purpose than those things, then you create your own custom view. So we're going to focus on drawing today, and I'll do gestures in the next lecture. To draw in your UI view, all you need to do is override this method drawRect. Okay? Very simple method, only takes one argument. In the code, it's actually called rect, but I've renamed it to be region that needs to be drawn so that people understand what that argument is. That argument is purely an optimization. It's just the system saying, hey, draw yourself, and really I only care about this rectangle of you. But you can draw the whole self if you want, but this is the only rectangle I really care about. So if you had a view that knew how to draw parts of itself, okay, then it could only draw the part that's in this rectangle. But you can completely ignore this rectangle if you want. It's purely an optimization. Okay? This is very important to understand. You never call drawRect. Ever, never, never. Okay? If you call drawRect in your homework, you're going to be major ding. Because I'm standing here in front of you with red text on my slide saying never. Okay? Do not call drawRect. drawRect is called by the system. Okay? It's called by the system when your view needs to be redrawn. How does the system know your view needs to be redrawn? Because somebody called setNeedsDisplay on your view. And you can call it on yourself if you want. If something has changed about your view, some property or something that would change the way it's drawn, you call setNeedsDisplay on yourself. Eventually, the system will call your drawRect. But it's got to set some things up first. Okay? And there's other views around you that it has to get organized. Okay? So never call drawRect, it's called for you. When you call setNeedsDisplay, you can specify, I really only need this rectangle redisplayed. And then obviously that rectangle is going to show up in the argument to drawRect. Okay? But if multiple people call setNeedsDisplay with different rectangles, probably the union of those rectangles might get called here one time for drawRect. Okay? Make sense? All right. So how do you implement this all-powerful drawRect method? You can use kind of a C-like function-based API called Core Graphics. That's what it's all based on. Or you can use a nice object-oriented thing called UI Bezier Path, which is what we're going to use because we like object-oriented. But since the underlying stuff, Core Graphics, is what UI Bezier Path is built on, I'm going to kind of explain a little bit about the concepts of Core Graphics, how one draws in Core Graphics. The first thing in Core Graphics that's important is you have to get a context to draw in. Okay? So if you're printing, you'll have a printing context. If you're drawing on screen, you'll have a draw on screen context, etc. And inside drawRect, when your drawRect is called by the system, it sets up the drawing context for you. So it's automatically set up. And it's called the current context, the current drawing context. And you can get it if you were using the C API, or C-like API. It's still Swift, but it's functional. Function API. You can get it with this function UI graphics get current context. And it'll return this cookie. It's just this magic cookie. You don't know what it is, but it is the context of drawing. Because all of the C-like functional API take a context as an argument. Okay? The Bezier path doesn't do that, no worries. But that one does. So the first thing you need is a context, automatically set up for you when drawRect is called. Then you create paths. You create paths with lines and arcs and things like that. Then you set the drawing attributes, like the colors you want to draw in, the line widths, things like that. And finally, you stroke and fill those paths. Okay? You can do either or both, stroking and filling. So that is fundamentally how you draw. Things like drawing text is just the fonts know how to have the perfect path to draw beautiful letters. And so your stroking would outline the letters, and filling fills in the letters, okay? So even drawing text is just stroking and filling paths, okay? Now, UI Bezier path, this object-oriented thing on top, it always draws in the current context. You don't have to worry about context. It has methods to do things like line 2, arc 2 to build the path. It also has methods for setting a lot of these attributes like line width and things like that. And it has methods to stroke and fill. So it combines all those core graphics things into one class. So let's take a look at UI Bezier path and how we would use it to draw a triangle, let's say. So first we create the path, so we just say UI Bezier path. There are other initializers for UI Bezier path, but you can also just create an empty path, and then you can start moving around. So here I'm going to assume this screen is 160 points wide by 250 wide, and I'm going to draw this triangle here. So I'm going to move to 80, which is halfway across, and 50, which is a little bit down. And then I'm going to add a line down to 140, 150. Then I'm going to add another line over to 10, 150. Then I'm going to close this path. Okay? So that's it. That's how you can make a triangle. Now, I'm kind of lying to you a little bit because as you execute these, nothing is appearing on screen. The screen will be blank. Okay? I was only showing them so you can understand what I was doing there with the lines. So it would be blank. To make it appear, you have to stroke or fill. So let's set the attributes we want. So I'm going to set the color for filling to be green and the color for stroking to be red. Okay, now notice that I set those with methods on UI color, not with methods on the Bezier path. Okay, that's a little interesting, but that's the way that works. But line width, I do set by talking to the path. So I send a message to the Bezier path, set line width to 3. So once I've set up all my attributes, now I can fill, for example, by saying path fill, and see, I get the rectangle filled in green, or I can say stroke, and it'll stroke the red line. Okay? Pretty straightforward. Most of learning to draw is all about understanding UI Bezier path and all the methods on it. Question back there.
If you had two paths on the screen, then how would you set different colors for those?
If you had two what?
If you had two different shapes on the screen.
Oh yeah, so the question is if I had two shapes on screen, how would I set the colors be different for each one? I would set the colors, stroke or fill one, set the color something else, stroke or fill the other. Okay? Question?
If the path isn't closed, what does fill do?
So the question is, if the path is not closed, what does fill do? Well, it depends on, I think, the winding rule and other things about how that draws, but it will try to fill it in. Okay? I mean, a path could cross back over itself, right? And so filling it might be hard to understand, and so there are rules for that. I'll talk about that just briefly in a second, but it will fill. But there are other things. If you don't close a path, then you can't do things like hit detection, right? Detecting whether a point is inside it because it's not closed, so there is no inside. So you can, UI Bezier path also has kind of pre-canned cool shapes like rounded rect, okay, which is a rectangle that the corners are rounded off of, or obviously ovals and circles. It has ways of doing that. You can also clip to any arbitrary path. So clipping, hopefully everyone knows what that means. That means if I have a path and I say clip, if I say add clip, then all drawing I do after that will only show up if it's inside that path. Okay? So, for example, if you were drawing playing card on screen, playing cards have little rounded rects. So you might draw your playing card in a big rectangle and then clip to a rounded rect so the corners get cut off. Okay? That's a kind of cheap, simple way to get a rounded rect playing card. You can also do hit detection, as I mentioned. The hit detection and the filling depends on the winding rules, and there's this uses even odd fill rule property, which is Boolean yes or no, to say which winding rule it uses. And so people who don't know what that means, don't worry about it. In fact, don't worry about hit detection and any of this stuff because you're not going to have to do this for your homework. But I just want you to know that Bezier path has a lot of other stuff besides just line 2, fill, and stroke. Okay, it has other stuff. You want to look at UI Bezier path. check out his documentation and kind of experience it in its full glory. Okay, let's talk a little bit more about colors, because I used a color there, that green color. UI color is just an object. It's really powerful. The colors not only can be standard colors like UI color.green color, but you can create a color from RGB, red, green, blue, or HSB, that's hue, saturation, and brightness. You can even set your color to be a pattern, so that when you draw with that color, it actually draws some image. Okay, so that's kind of cool. Views have a background color, which you can set on them. Also, colors can be transparent. Okay, they can be see-through, partially see-through. This is called alpha. So alpha is a value between 0 and 1. 0 means fully transparent. You can see completely through it. It won't even show up on screen. To 1, which is fully opaque. It obscures anything behind it, anything drawn with this color. And you can create a transparent color from another color with this color with alpha component. This would create kind of half transparent yellow color to draw with. And you can draw in your view with these transparent colors, okay, using these Bezier paths. However, if you draw in your view with transparency, you must tell the system that you are going to do that. And you do that by setting this property on your UI view called opaque to false. And why is this required? Well, because drawing with transparency is expensive, because the views behind you are going to start showing through. Okay, so the system has to blend basically the different views that are overlapping. That's expensive in terms of graphics power, and so it doesn't want to do that if it doesn't have to, if it can just draw the bits. If you don't set this to false and you try drawing transparently, it's not going to work, okay, because it's not going to blend with the things behind. You can make your entire view transparent, okay? It has its own property alpha, which you can set to anywhere between 0 and 1. It'll make your view, everything you draw in the view will be however much transparent you want it to be, okay? What happens when views overlap and enhance transparency? They're blended, as I said. Remember that the subviews order matters. Okay, the thing that's first in the subviews array is in the back, and everything down the right is in front. So when the transparency happens, that's the order it's going to happen in. You can completely hide a view by setting its hidden equal to true. And this is surprisingly common, to just hide a view, and maybe it appears when a certain condition is true on screen or whatever. You can set up this view in your storyboard and then set it hidden to true, and so it comes up, it's not there, and then in code you say hidden equals false, boom, it appears. Okay, so that's a way to completely hide the view. A hidden view not only doesn't draw, it doesn't receive any touch events either, but it's still in the view hierarchy. It's kind of there waiting. Okay. All right, drawing text. So usually you draw text on screen with a UI label. That's what you did with your display, etc. But you might want to draw in your drawRect, and you do that with this class called NS attributed string, which I'm really not going to cover. You want to look at its documentation if you want to draw text. I'm not going to do a demo of NS attributed string, but I'm going to give you some code for your assignment next week, and I'm going to use NS attributed string in the code I'm giving you, so you'll be able to see an example of how it's used. But basically, an attributed string is a bunch of characters and some attributes on those characters. Now, attributed string has a couple of interesting things about it. It's easy to use. You can just create it, pass it a string, and then say draw at point, and that will draw the string with its point, its upper left corner, at that point. And you can even find out how big it's going to be by asking it the size of this attributed string. So it's pretty easy to use in that way. Mutability is not done with var and let. For NS attributed string, there's a different class called NS mutable attributed string, okay? And why would you want a mutable attributed string? Well, because these strings, what makes an attributed string attributed is you can put attributes on the characters in this string. And so a mutable attributed string, you can set the attributes. You can get the string out as an NS string using the string property on NS attributed string, but NS attributed string itself is not a string. It's not like a subclass of NS string or anything. It's its own thing. So you set these attributes with functions like set attributes. It takes a dictionary of attributes. I'll talk to you about what the keys and values are in a second. And then a range. That's an NS range right there, by the way, not a Swift range. And the indexing into these strings is the old style NS string version. It's not this string.index stuff we talked about last time. It's literally which Unicode character are you talking about setting an attribute at? Okay, so this dictionary has a bunch of attributes. The attributes can be things like set the foreground color of this text. Okay, set the stroke width. Okay, because remember, text is just paths. You can stroke them and set the width. Or the font is a really important one to be able to say. Set this text to have this particular font. Okay, and so you just set a dictionary that has the key NSFont attribute, and the value would be a UI font. Okay. Now let's talk about UI fonts briefly. Fonts in iOS 7 and later, including iOS 8, are very important to get right. Okay, look at these screenshots. Look how important the fonts are. Okay, they're critical to making the UI look good. Okay, so you got to get the right fonts in your app. And where do you get the right fonts? Well, the number one place to get a font, the right place 99% of the time, is this class function in UI font called preferred font for text style. Okay? The text style is something like a headline or a body. Okay, the body would be like the main content that your user is looking at. Headline might be like a title at the top. Footnote might be a small little thing mentioned at the bottom. Okay, and there's a whole bunch more of these text styles. And so you're going to ask the system, give me the preferred font for that style. The font includes a size. Okay, UI fonts include the size as well as the face. And users can go into their settings on their phone and change and say, oh, I can't see anymore, like me, and they make their fonts bigger, okay? And so this would automatically get that new size. Okay, so that's why you always want to use preferred font anytime you're displaying any user content, okay? Now, it is possible to create fonts where you say, give me Arial 15 narrow, or what. It is possible, but you really shouldn't be doing that. You should be using this preferred font for style. There's also a system font. This is something that appears on buttons and in things like segmented controls, things like that. You never want to use one of these system fonts for user content. User content, you want to use the preferred fonts. Okay? So yeah, other ways to get fonts, ignore them. I'm not going to talk about it. Okay? All right, how about drawing images? How do you do that? Well, there is a UI label for images. It's called UI image view, and you can use that to put an image on screen, but you might want to draw an image in your DrawRect as well. And usually you create an image by name from that images.xc assets thing that we moved out of the way real quick right at the beginning of our very first demo. And if you click on that, it's pretty self-explanatory. You can drag images in. You can have different images of different resolutions for different devices. It's really pretty powerful. That's usually how you create an image, is by name and dragging it into the images.xc assets. You can create it in other ways from the file system, which we haven't talked about, or even with drawing. We're not going to talk about that either. Once you have a UI image, you can draw it by just sending it the message, draw at point. And it will draw in its normal size with that point as its upper left. You can also say draw in rect, and it'll scale to fit that rect, either bigger or smaller. Or even draw as pattern in rect, it'll tile it repeatedly to fill the rect. Okay? So really easy to draw images inside your DrawRect. The last thing I want to talk about is what happens when your bounds changes in your UI view. Like the user rotates the phone, and now your bounds are wide and not very tall instead of tall and not so wide. You might think, oh, my DrawRect's going to get called, and I'm going to redraw. But no, that does not happen. Instead, the bits that were on screen get stretched. Okay? So usually that's not what you want, because that's going to result in a very grainy kind of bit stretching of your UI. But that is the default, is the bit stretching, because it's high performance. Now, you can control what happens to your view when the bounds change with this property in view called content mode. And here are some of the content modes you can set. There's left, right, top, bottom, etc. All these ones basically don't change the bits. They don't redraw, but they just move your entire view to the left edge, right edge, top, or bottom of the new bounds. These are kind of strange ones. Probably don't need that very often. Then there's the scaling of the bits. So here's the default, scale to fill. Okay, we'll scale the bits to fill the new bounds, but you can also fill or fit the bounds and keep the aspect ratio so that it won't stretch your bits. It'll still scale them, but it'll scale them with your aspect ratio maintained. Or you can have the wondrous redraw. Okay, this is the one you want to set that says, when my bounds change, call my DrawRect again. Okay, with the new bounds. So you're going to want that quite often. I'll show you that in the demo today. All right, so let's get right to this demo. Okay, it's going to be a little tight to do this in 20 minutes, but because we're going to cover a lot of stuff, but I think we can do it. We're going to start by creating a new project. So I'm just going to file new project. This is a brand new. Okay, we're going away from the calculator here. And as always, we're going to be using this single view application thing right here. I'm going to call this project happiness because we're going to draw a face, a smiley face. Okay, and it's going to be able to smile or frown depending on how happy it is. Okay, so that's why we're going to call this happiness. I'm going to put it in the same place I put my calculator, which is my home directory developer there. Here it is. As before, I'm going to move this app delegate out of the way. I'm going to move, actually, let's take a look at image.assets. So here's the app icon slots. You can see that for any given image, like the app icon, there's lots of different resolutions depending on the devices that you can provide. Okay? You don't have to provide all the different resolutions. It will interpolate, but you can do it. So you just drag an image into here, and now you can get it by name with that UI image named function. So we'll get that out of there. We don't have the launch screen either. So here we are. I'm going to show you something fun here too. Here is my storyboard. I'm going to show you how to add a new view controller to your storyboard. And in fact, I'm going to delete this one. So see this one right here? I have it selected. I'm just deleting it. It's gone. I'm going to delete its code as well. I'm going to go here and just delete, move to the trash. Now I have a storyboard with nothing in it, and I have no view controllers. Okay? So how do I add a view controller? You go over here to your object palette. The very first thing is a view controller, and you just drag it out. Boom, you get one. Now, the class, what class is this going to be, though? This is going to be generic UI view controller, so it's pretty useless. Okay, you can't add any outlets or have any actions because it's not a subclass of UI view controller, so you can't put any of that implementation in. So we're going to create a new subclass of UI view controller. So let me show you how to do that. You say new file. And last time we went to new file, we said Swift file to make the calculator brain. But now we're going to go over here to Cocoa Touch class, which we do anytime we want to create a subclass of an iOS class. And here I'm creating a subclass of UI view controller. I need this. So I'm going to click on that. Here's where I pick what I want it to be a subclass of. You can see a lot of things in here. I'm going to say I want a view controller. It wants to call it view controller by default. We don't even like that for the calculator, let alone this. I'm going to call this my happiness view controller. Okay? So it creates that. Put it in the same place all my other Swift files are. Here it is, happiness view controller. Again, I'm going to get rid of this code. Okay? Just to make things a little clearer. So here's my happiness view controller. It's just like the view controller you had that was called view controller in your calculator, but it's called happiness view controller. But this guy right here is still plain old view controller. How do I know that? Well, it's this magic right here. You see this identity inspector? Okay, you can see the class of this selected thing here, and it's a UI view controller. And I don't want it to be a UI view controller. I want it to be happiness view controller. So very important to understand that in storyboards, everything is linked up to your code by name, only by the name. That is the only thing that links what's in your storyboard with your code. The names of outlets, the names of methods, the action methods, the name of your UI view controllers, the name of your UI views. Okay, it's all by name. So you have to go to the identity inspector here and make sure that name matches up. So now you can see this says that it's a happiness view controller, so that's making me happy. Okay, now we want to put our custom view in here. Okay, so how do I add a custom view to my UI? And the answer is I go into the object palette. It's all the way at the bottom, near the bottom somewhere. Where is that thing? There it is. You can drag out a generic view. So this is just a UI view. Now when I drag it out, I'm going to put it right here with the dashed blue lines, okay, because we know that that's a good thing to do. And I want to set up the auto layout so that this view always fully fills my, my scene here. Okay, now I could control drag to the edges like I did before, but since this is already perfectly where I want it, and I use the blue lines, I can go down here and use reset to suggested constraints. Okay? Now, I'm only showing you drips and drabs of auto layout. I was going to talk all about auto layout today, but we need to move on to this. But I will be having a lecture on auto layout probably week after next. In the meantime, I'm just going to show you little bits of it and you can explore. I'm never going to ask you to do a ton of it in your homework. So this one I'm going to reset to suggested constraints, and it added those constraints. And I could go over here. Let me make some more space here. I could go look at them over here. You've all determined that. Another place you can see the constraints of a view is here in the size inspector. If you look towards the bottom of the size inspector, look, here's all the constraints. See, trailing, leading, top, bottom. It added all these because these are the suggested constraints based on the dashed blue lines that I used. Okay? So oftentimes, if you put something in place perfectly with the blue lines, you can use reset suggested constraints. We could have done that with our display in our calculator. We couldn't do it with the buttons because it just wasn't lined up enough with other things. But we could have done it with the display. All right, so now we have this. Now, this UI view, let's look at its identity inspector. It's just a generic UI view. That's no good. We need a custom UI view subclass. So let's go do that. File, new file. Same thing, I'm going to create a subclass of a Cocoa Touch class. This one's not going to be a view controller, it's going to be a UI view. Okay, I'm going to call it face view because that's what it's going to do. It's going to draw a face. Okay, put it in the same place, put everything. Here's my face view right here. We'll get back to that in a second. In our storyboard, we want to make sure that we inspect our face view, okay, and change its class to face view. By the way, it can kind of get tricky sometimes picking the right thing. Like sometimes you're picking the UI view controller, sometimes you're picking the view. One kind of cool trick, Control Shift. If you hold Control Shift and click, then it lets you pick which thing you want that's under the mouse. It's a very important little trick, Control Shift. So here I could pick the view controller. Now I'm seeing the identity inspector of the view controller. Or I could go here and pick, this is the view property in my view controller, the top level view. This is my face view that I'm trying to create. So I select this here, and I'm going to go to the identity inspector again up here. I'm going to change this to be a face view. Okay? So now this thing is a face view. And so when it's time for this thing to draw, it's going to call the drawRect of the face view class. So let's go take a look at the face view class. Here it is. And here is drawRect. Now, it's commented out by default. Why is it commented out by default? Well, because having a drawRect costs system resources. It thinks it has to draw this thing. So you only want to have a drawRect if you actually draw in your drawRect. Don't have it just sitting there uncommented out if you're not actually using it. All right, so how am I going to draw this face? Let's start by drawing the outline of the head, just a round circle, okay? Because that's pretty simple to draw. And how am I going to do that? Let's start by creating a Bezier path. I'll call it face path, which is Bezier path. And let's look at all the different kinds of Bezier paths we can make. Ovals. We could use this one, oval and rect. Okay, that's a pretty good one. I'm actually going to use this one, arc center, because I want to show you a really bad error message you're going to get in Swift that I want you to avoid. So I'm going to use this one, which lets you create an arc, and I'm just going to have my arc go all the way around, okay, from 0 all the way around. So it wants to know the center, so I'm going to have my face's center somehow. We'll define that in a second. It also wants to know the radius, so I have to have my face's radius in a second. We'll do that. It wants to know the start angle to draw this arc. Okay, so I'm going to start at angle 0. The angle is in radians, so I want to go around to 2 pi. I'm going to draw an arc from 0 all the way around to 2 pi radians. Hopefully everyone knows what radians are. Okay, so 0 to 2 pi, that's good. And then clockwise or counterclockwise, I don't care because I'm going all the way around, so I'll just say clockwise true. Now, when I do this, well, first let's do our face center and face radius here. So I'm going to make actually computed properties for those. So the face center is a CG point, and really it would be cool, yeah, I could do get and set. It's going to be get only. Okay, I'm not going to allow me to set my face center. I'm always going to calculate it. I could make it settable, actually, too, but I'm going to make it so it's calculated only. When you do calculated only, you actually don't need this part, this get. You can take that out, okay, if it's return only. So I'll say return. Now, you might be saying, oh, I'm going to return center. Let's put the face in the center. But everyone understand why this is very bad? Right? Because center is not in my coordinate system. It's in my superview's coordinate system. Luckily, I can convert a point from my superview's coordinate system using this nice method, convert point from view. So I'm going to convert center from my superview. Okay? That's going to put my face right in the center because I've converted that center from my superview's coordinate system to mine. Okay? So that's face center. Let's also do face radius. So for the face radius, I'm going to have it be as big as it can be. Okay? So face radius is going to be a CG float. All of our drawing stuff is float. And I'm going to return as big as it can be without getting cut off. So it's going to be the minimum of my width or height. So I'm going to say min of my bounds, bounds.size.width or my bounds.size.height, whichever is less than that. Min is just a nice little function in Swift. And I'm going to divide by 2 because this is a radius, not diameter of my face. This is the radius. So now I have my center, face, and radius, but I still have an error here. Look at this error. Even though I did my center, I did my radius, I still have an error. What is the problem? Oh, extra argument, radius in call. Huh, that's weird. I didn't see any extra argument. What the heck is that about? Okay, you could waste a half an hour looking for this, okay? Thinking, oh, radius, there's nothing wrong with the radius. It's right. The problem for this has nothing to do with the radius. The problem is this, okay? So this is an error you get from Swift, and occasionally, I'm sure they'll fix all these errors, but occasionally you get this very misleading error, and this is one. The problem is that this, what type is this? It's a double. Yeah. And what type do we draw with? CG float. So this problem is just that I need to cast this to a CG float. Okay? That's going to make this error go away. It has nothing to do with radius whatsoever there. Okay? So that's warning. Watch out for that. All right, so I have my nice face path here. Maybe I want to set my face path's line width, something like 3 or something like that. In fact, maybe I even want line width to be something that's configurable in my face view. So it's a CG float, and we'll set it to default of 3. One thing that's interesting, and then we'll set this down here to line width. One thing that's interesting about this is anytime someone changes my line width, I need to redraw myself. Right? So how can I make that happen? Well, I can use property observer. Okay, anytime someone sets this, I'm going to call set needs display on myself. Okay, bam, I'm going to get redrawn by the system. Okay, so anytime you have a property in a view that changes how you would be drawn, just put a little property observer and do a set needs display after it. You'll automatically get redrawn. Maybe I'll have another property here, which is the color I want to be. UI color, we'll set the default here to be blue color, for example, and I want the exact same thing here. Okay? If someone sets it, I want to redraw. And so let's go ahead and set our color. Now I'm going to do both my set, I could do set fill and set stroke colors, but I'm just going to do set, which sets both my fill and my stroke. I'm not going to be filling, so it doesn't matter, but I'm sets them both. And then how do I draw this Bezier path right here? I just say face path dot stroke, and that's going to draw. Okay? So let's go take a look at this. Put this down here. Run. Okay, so it comes up, it's blank. And not only is blank, it's got some error down here. What does it say? It says failed to instantiate the default view controller. Okay? Well, that means that in my storyboard, there is no scene that's specified as the scene to start in. Okay? It has no starting scene. The starting scene always has a little arrow pointing to it. Right here. You've probably seen it in your calculator, right? A little arrow says this is the place to come in when you start this app. You can set that arrow with the inspector, the regular attributes inspector, by selecting your view controller that you want to be the one that comes in. And click this little button here, is initial view controller. You see that arrow appeared? You can also pick this arrow up and move it to another view controller. Okay? So now we have a thing. Oh, all right. So we've got our face. Now, one thing I don't like about this face is it goes all the way to the edges. I want it to actually be like 90% from the edges. Okay? Another thing I don't like is this. Ugh. Okay? So my face is going to be distorted every time I rotate. Why is that? That's this stretching thing I was telling you about. We want our draw rect to be called again when we have a new bounds like that. So let's fix both of those things. We can fix that content mode redraw by selecting our view, going to the inspector up here, the attributes inspector, and the very first one is the mode, and you can see the default was scale to fill. We want redraw. Okay, so I'm going to pick redraw, so that'll fix that. And as far as the 90%, I'm going to fix that in here by having my face radius be times 90%. But really, I'd like this to be settable too, so I'm going to have var scale CG float. Okay, and we'll start this out at 90%. So I want that, and this one also, if I change, I want it to change. Okay, so now let's go try that. See what happens. Okay, we got our 90%. That's good. And when I rotate, it doesn't stretch it. Okay, and it's using the minimum of the width or height. Okay, so that's good. That's going good. Now we want to draw the eyes and the mouth, and because time is running out here, I'm actually going to type those in super fast. I posted it for those of you who are trying to keep along here, which is probably impossible. To do that, though, I need some constants, and this is how we do constants in Swift. We create structs, okay, and then use class, or in this case static, lets. Okay, so this is going to be a constant called scaling.faceRadius to iRadius. Okay, and then I'm going to have a function here that I'm going to type in really, really fast called Bezier path for eye. And it's just going to return a Bezier path that draws an eye, either the left eye or the right eye. This says which one. Okay, see it returns a Bezier path. Okay, then I'm going to have another one, which is Bezier smile. I'm going to type that in real fast. Okay, so here's Bezier path for smile. And what this is going to do, it's going to take a fraction of the maximum smile. So 1 is full smile. -1 is full frown. And everywhere in between. Okay, so that's what this does, and it returns a Bezier path. So now here in my draw rect, I can say Bezier path for eye, left eye. I got the Bezier path. I'm just going to immediately send it stroke. Okay, and then Bezier path for the right eye. I'm going to send it stroke. So I'm just going to stroke the left eye and the right eye. Okay, then I'm going to do the smiliness. So I'm going to let smiliness equal some value. Let's start it at 0.75. We're pretty happy to start. And then I'm going to create this Bezier path using this thing up here for a smile, which is Bezier path for smile. And we're going to pass it the smiliness. And then I'm just going to stroke this smile path. Okay? Now I hoped I had a little more time so I could have gone through this code, but it's pretty straightforward code, really. Here we're just using add curve to point in our Bezier path to draw a curve, which is the curve of the mouth. And then here we're just using Bezier path arc center again, okay, to create the circle. The eyes are just circles. Okay? That's really all those two methods do. There's nothing really special about them. And what do I have error here, which is, oops, dot. Okay? Oops, that's not it either. Smile path, oh, equals, not dot. Equals. There we go. Okay? Yes. So let's run this. Hopefully we'll have a smiley face. There it is. He looks pretty happy. We can rotate him. Ooh, he's very happy. Okay, let's make him a little sad. How about minus 0.5? Minus 0.5. That's pretty sad. Aw. Okay. Okay, so now we have this nice face view. What we're going to do in our next lecture is we're going to add a gesture so we can make them happy or sad. Happy or sad, okay? We're also going to put a gesture in there, a pinch gesture, so we can make them bigger or smaller, okay? Then we're going to actually add a whole nother MVC and make a much more powerful application that just uses the face view, the happiness view controller, as a view in another MVC, okay? So now we're going to do multiple MVCs. So that's what we're going to be doing on Monday.